what I wanted to talk about today is this. We started discussing some things about network and network security. We started talking about network devices. We started talking about network protocol analyzers, and we started having hands-on practical experiences using two network protocol analyzers, and the two of them are TCP dump and Wireshark, right? So and this is the lab setup. So in cybersecurity, you have a lot of lab activities we use for practical demonstration. Because of how sensitive cybersecurity is, it is not really legal for us to start scanning through IP addresses or MAC addresses that we don't have. So scanning through IP addresses that doesn't belong to you is actually illegal. So what we do now is that we get these labs together and then use them to practice all we need to practice. So I have my Kali Linux, which is Linux operating system set up. I have a Metasploitable 2, which is also acting as a vulnerable machine that we use to scan and do all the things we'll be doing. I have Cybersecurity Lab VM workstation from Cisco. I have the CyberOps Security Onion. These are different lab activities we are using. Today, there's an activity I want us to do, and for you to be able to do that activity, you have to install this particular visual machine. This is the Cybersecurity Lab VM workstation. Cybersecurity Lab VM workstation. So I'm logging in, and the password to log in is CyberOps. The password to log in is CyberOps, and I'm going to make this particular lab available to everyone. I will upload it in our folder so that all of you can be able to download it and set it up. Those that can meet me physically in my office can of course come, and I'll help you set this particular lab, set this particular visual machine up so that you can use it to practice everything you are learning about network and network security. And so, having said that, let us look at that activity. And the activity is here. Where is it? I think I downloaded it. So that activity is for us. So it has to do with Wireshark. We need to understand how to use Wireshark to capture packets and analyze packets. Wireshark is a network protocol analyzer. Let me open that particular activity. I think it's here in my module 5. Then introduction to Wireshark. Introduction to Wireshark. So if you're in this class today, what are you learning? I attended the online class that was hosted by Mr. Dennis, Digital Assessor, on 13th. Today is 13th at B12, on 13th of August 2026. And in that class, Mr. Dennis was talking about Wireshark. And what is Wireshark? Wireshark is a packet analyzer. Wireshark is a network protocol analyzer. It is a packet sniffer. Right? And remember, I talked about packet sniffing. Packet sniffing is a tool we use to capture, to analyze, and to actually monitor data traffic in a network. Right? So, and there's an activity. This activity here is a lab activity from Cisco. Look at it here, Cisco Networking Academy. That is where I got the lab activity from. It is very, very powerful, and we are going to be using it. Then in the lab activity, there are a lot of instructions we need to carry. And when you carry this instruction line by line, you'll be able to understand how to use Wireshark to actually capture data traffic. So what do we need to be able to carry out this particular activity? We need our CyberOps VM workstation. All right, CyberOps VM workstation, which of course I have downloaded and installed. Look at my CyberOps VM workstation. Look at it here, Cybersecurity Lab VM workstation. That is what you need in order to carry out this particular activity. Alright, so now look at it. I've opened it up. The step 1 here is that we need to set up a mini net. We need to set up a mini net, and that mini net will help us to actually understand. We are going to set up a simple network topology. Look at the network topology we are going to be using. The objective of this particular activity is for us to install and verify the mininet topology, then capture and analyze ICMP data traffic data in Wireshark. The CyberOps VM includes a Python script that when you run it, you'll be able to set up and configure the devices as shown below. Now, let me zoom this thing in small so that you see. What you are seeing here is a simple network. What you are seeing here is a simple network, and we already know what a network is. It is a group of devices that are communicating with each other, and this is a simple network topology. Alright, now what can you see here? Number one, you see that there is a host. This H1 stands for host 1. This is one host, and this is another host. Remember, a host is just a device that is part of the network. Let's just assume that this host here is a computer. So we have one computer, another computer, and this is the third system, the third computer, which is host 3, and the fourth computer, which is host 4. Then we'll have this is a switch. This is a switch S1, and this one is a router R1. Now let me say something that is very important. For you to be able to set this type of network physically, right, it is going to cost you not less than 1 million. So that you understand the reason why we use lab, you understand the reason why we use virtual machine. For you to set up this network physically, you need to buy like 4 laptops or 4 computers, and then buy a switch and buy one router and connect it like this, so that these devices will be communicating with each other. There will be exchange of packets among these devices, and it is very expensive for you to set up physically. Now, what do cybersecurity professionals do? We set it up virtually, right, using Mininet. Mininet is just like mini network, so it will help us to set up this particular arrangement virtually. Instead of buying this physical laptop, we just set it up. There is a Python script that we've used to set it up inside this lab. So this lab is coming with the setup. All we need to do is just to run that Python script. And if I open the lab here, the Python script is actually located in the home directory. That is why, remember, I told you guys that we need to learn Linux. You need to understand Linux properly, understand Linux to the core. So if you are still having difficulty understanding the Linux command, you let me know. So if I do ls here, inside this particular directory here, let me even do pwd. Pwd stands for print working directory, and of course when I run pwd, you can see that my working directory is analyst, home/analyst. So I am currently in the home directory of analyst. Alright, so if I now do ls to see the contents of the information in the home directory of analyst, you see that inside the home directory of analyst, there is a file here called cisco-traceroute.txt. There is desktop, there is document. These ones that are blue in color, of course, are folders, they are directories. And so there is a Python script that is inside this lab.support.files. Right, there's a Python script there. Let's locate that Python script. So I will cd into lab.support.files. cd means to change directory. So now I've logged into lab.support.files. If I do ls to check the content of that directory, you see that these ones that are white in color are files, while the blue one are directories. You see why this lab keep on disturbing me? Mr. Dennis, please make sure you send me this lab. I need this visual machine. Send me this particular visual machine. The visual machine you used to perform that Cisco lab activity where we tested our knowledge in Wireshark. Please send it to me. Keep on disturbing what I send it to you, especially if you cannot meet me physically. This lab, I don't know how many gig it is, but I know I can upload it to a Google Drive. Those that are not with me physically can download it and then install. So now that I logged into this lab.support.files, this is a folder. There are other files and folders inside it, and that particular the script you are looking for is inside the folder called script. So this folder here, this is a folder called script. So I want to cd into that folder to locate that script. Cd scripts. cd means change directory, if of course you are not aware. If I do ls, I will see that inside that folder there are a whole lot of files. The files that are these ones that are green in color are executable file, and if you check it, you see cyberops_topo.py. This is the Python file, the Python script that we need to run. You see that it is executable. This is the Python script we need to run in order to set up that network topology that is illustrated here. Right, so we will run the Python script, and then it will set up this topology inside that our lab, and we can be able to carry out the activity. So I just wish that we'll have enough time to be able to complete it. So, but let us just begin. I'll be as fast as possible. You can always watch the video over and over again and practice it once you get access to this lab. So I will do cd TID and get back to home, and then run the full command. The full command is sudo. I will run this command, and if I have any of my advanced students there, I will ask the person to try and actually interpret what I ran here, what it will do. Alright, support.files, support.files, forward, let me do this, scripts, okay, / script, then / cyberops.topo.py. And so who is on the call? Let me know whether there is anybody that can interpret what this command I ran here will do. If you are here and you can interpret what this command is doing, alright, you can unmute yourself and let me know. So let me know, Roy, so that I can be learning in the process. Who is here? If Ogona is here, Ogona might know. Okay, Ogona is not here yet. So if you check this particular command, what you are going to see is that sudo stands for super user do. Sudo stands for super user do. This is the command we use to give ourselves elevated privilege when we want to perform any activity that requires us to be admin. We use this sudo to give ourselves an admin privilege. Now, this sign you are seeing here is called TID. Alright, in case you don't know, that sign is called TID. Look at how to spell that TID. TILDE. Alright, we call it TID. So many people call it TID, something like this, TID. That is what it's called. And that TID here is the short form for home. Alright, is the short form for home. So I ran this sudo from home because that particular script we are looking for is cyberops.topo.py. It is found inside the script directory, and the script directory is found into the lab.support.files. So once I run sudo, I use sudo to execute that file, and if I hit enter, it will ask for the password of analyst, and the password is cyberops. So I'll type the password and hit enter, and of course the command is not found. Let me know where the issue is coming from. lab.support.files, then /scripts /cyberops.topo. Okay, so the error is coming from somewhere here, cyberops_topo. Alright, and then I'll hit enter and put my password again, cyberops, and then sharp. So the script has run successfully, and if you check here, this script has been able to configure that CyberOps network topology. Check it out so that you see that it has been able to set up this network. This is the router, this is the host 4, this one is the host 1, this is the host 2, and this is host 3. What it means is that we're able to set up a network where we have 4 devices communicating with each other with a router as a network device and a switch. You know what a switch does in network? In a network, a switch helps to actually send data packets to the specific device that it is meant for, while router helps to connect 2 networks together. Right? That is what router does. Router helps to send data packets between one network and the other. So now when you check here, you see that the network topology has been set. That Python script started running, adding layers, creating network, adding hosts. 4 hosts were added, R1, R2, H4, and then R1. Then adding switches, adding links, starting one switch and the other. So after that, you see that the mini net has been set. That mini net stands for mini network. That mini network helps us to actually design. It helps us to actually create a network virtually instead of trying to buy the devices physically to set that network. So that's what Mininet actually does. So let's go through this activity. Remember that we are doing an activity, and this exercise and this lab requires us to install and verify the Mininet topology, which we've done. We've been able to install and verify the Mininet topology. Then the next thing we need to do is that we need to actually start these two hosts. All right, let me show you something. Remember, we have host 1 and we have host 2. So here in host 1, all I need to type here is I'll type xterm. This xterm stands for X terminal. So I want to start the terminal for host 1. Right, if I hit enter here, I'm starting the terminal for host 1. So host 1 is a device, and this is the terminal I started for that particular device. Let me go back to the terminal here and also start another terminal for host 2. I will start another terminal for host 2, H2. And if I hit enter, you see that two terminals are now running. The first terminal here is for node for H1, and then this one is the node for H2. So what it means is that two of these terminals are actually running. So in the first terminal, I will check the IP address of this device in host 1. The command to check the IP address I can run IP address and hit enter to check the IP address. I can even do ifconfig and hit enter. So when you run ifconfig here, you are going to see that this particular device, the IP address is 10.02. This is the IP address of this particular device. All right, you know what IP address is. We've done a whole lot about IP address, and anybody that has questions regarding it, I'll still ask. This is the IPv4 address, and this one is the IPv6 address of this particular device. And then look at the MAC address. The MAC address is this one under ETA. That is the MAC address. So, and what else is there? These are the important addresses that relates to this particular host, which is H1. And the lab activity requires us to document and write down this IP address. So when you are performing this lab activity, once you get this virtual machine and you are doing it, you need to create another file. Then the H1 IP address, you write it, and the H1 MAC address, you write it. If you check here, I've shown us the H1 IP address, which is 10.0.0.12, and the H1 MAC address, which is B6 6F and all the rest. This is the MAC address. What is the MAC address? MAC stands for Media Access Control. This is the address that is given to our system by the network, by the manufacturers. And this address is written in the network interface card. And the IP address, of course, comes from the internet service providers, and it changes from time to time based on location and the network you are using. So now we can write down the IP address of this device, and then let's go to node 2, which is H2. In H2, okay, I ran that for H2. In H2, you can also check the IP address of H2 by running ifconfig. So if I run ifconfig in H2, of course, you see that the IP address is 10.0.0.11. This is the IP address of the second host. Remember, a host is a live system. This is the MAC address of this host 2. That is it. So right now, where are we? We've been able to gather information about the IP address and MAC address of H1 and H2, which is the host 1 and host 2 under the H0 interface. So you just write the IP addresses and then the MAC addresses. So in the second part, which is part 2, in this part, you are going to ping between two hosts in the Mininet and capture ICMP requests and replies in Wireshark. You also look into the captured PDUs for specific information. This analysis should help you to clarify how packet headers are used to transport data to the destination. Now, what do we do in order to achieve this? We have to actually examine the captured data on the same LAN. So if I open this, of course, you know, this is where Wireshark now comes in. What we want to do here is that in this network now, we have 4 hosts. But right now, we want to work with 2 of the hosts. The first host here is the H1. As this H1 is a host, it is a device in this network. And we've been able to get the IP address of this device, and we've also been able to get the MAC address of this device. These are the addresses that we use to identify any device in a network. This is H1. And then we now have another device, which is H2. We also got the IP address of this H2 and the MAC address of this H2, which is another device. So now we want to establish connection or connectivity between these two devices. That means this device is going to communicate or send data packets to this device, and this device is also going to respond to the data packet. And the type of data packet we want to initiate is ICMP. ICMP stands for Internet Control Message Protocol. If you've been a fan of cybersecurity, you know that ICMP is a management protocol. We use it to actually check connectivity. We actually use it for troubleshooting network connectivity. So we want to initiate ICMP packet, exchange of ICMP packet. This H1 is going to send ICMP echo request to H2, and H2 will now reply with ICMP echo reply. Alright, so now what we now want to do is we want to use Wireshark, which is a network protocol analyzer, to capture the data packet. So as these two devices are communicating, Wireshark is going to capture the data traffic, and we'll now use Wireshark to analyze the data traffic. So that is what we want to do now. So we are in host 1. We are going to be in host 1, and in host 1, which, how do I know we are in host 1? You check here, this is node H2. Okay, we want to go to node H1. This is node H1. So inside this node H1, we are going to start Wireshark. Alright, so we'll just type this command to call Wireshark, and I'll use this ampersand to open it. So this is Wireshark, it is running. And this is how the Wireshark looks like. Wireshark, what can you say about Wireshark? It is a network protocol analyzer. It is a graphical user interface network protocol analyzer. We use it to actually analyze data traffic. We use it to analyze network packets. So Wireshark can capture data traffic and then analyze it. Alright, so this is the Wireshark, and the interface we are going to capturing from is H1 Ethernet 0. So I'm going to click on this H1 Ethernet 0, and I will start capturing. I will click on capture for me to start capturing. But there is one thing you need to learn and understand about Wireshark, and let me show you here. Wireshark actually has 3 sessions. Right, Wireshark has 3 sessions where it displays PDU. This PDU stands for packet data unit. Alright, protocol data unit, or packet information. That is what that PDU stands for. Now look at how the Wireshark interface looks like. The first top session, this top session here, is where Wireshark arranges all the data packets based on their frame. The frames are numbered, frame 1 to, or 1 package to the last, and then it will contain the time the packet was captured, the source address and destination address. Then this particular second, this middle layer is where if you select a particular data packet on the top layer, the middle layer will now give you detailed information about the data packet, like the Ethernet, the internet protocol, and the user datagram protocol. All of that information about the data packet will be displayed here in this middle layer. Then in this last layer, this is where the information is displayed in hexadecimal. You know, we cannot be able to interpret. That's why they say here the bottom section displays the raw data of each layer, and the raw data is displayed in both hexadecimal and decimal form, which of course we don't have any business interacting with hexadecimal and decimal form. But the form that we can understand as human being is this top layer. This top layer is now where the data packets lists are displayed. It displayed the list of PDU frames captured with a summary of the IP packet information that is listed. Then the middle layer will now list the PDU information for the frame selected. So now that we've been able to understand how Wireshark works, and this is the Wireshark interface, we click on the Ethernet, which is the H1 Ethernet we want to capture, and we'll start capturing. And when we click on start capturing, we want to go to our H1 and initiate ICMP data packet. So I click on H1, and if I hit enter here, I will be able to pull up my this, and then I will ping. This ping stands for -C. Let's just send 5 data packets to our host 2. Host 2 is 10.0.0.12. So this host 2 now, this is the second device. Remember what you are doing here. We are in host 1, and the host 1 want to send data packet to host 2. Right, so, and the type of data packet we want to capture is ICMP, and we use ping to send ICMP data packet, and we are sending it to host 2. So we are using the host 2 IP address, which is 10.0.0.12. Right, and we'll now hit enter and see what the result will look like. So when I hit enter here, of course, you see the 5 packets has been transmitted, because this -C is what we are using to indicate that we only want to send 5 data packets. So 5 data packets has been transmitted, 5 received, and 0 packet lost. Right, so now we can now go to our Wireshark and check. You see that Wireshark has been able to capture the data traffic. I just hit on this stop. I stopped the packet capture. You see that this process that took place inside this host 1, we use host 1 to send 5 ICMP data packet to host 2. So what is ICMP? Internet Control Message Protocol. And what will happen is that it is used to check whether host 2 is active. It will send ICMP echo request, and host 2 will reply with echo reply. And that is what we are seeing here. Look at the data packets here. We have there is ARP, others are ICMP. So in Wireshark, there are some filter. You need to also learn about the Wireshark filter. Like now, if I type ICMP in this display filter, this area here is the display filter. If I type ICMP, that means I want to filter and get only the ICMP data packets. And if I hit enter, of course, you will see the ICMP data package, which is this pink. You see it. So the source IP is from 10.0.0.11. This 10.0.0.11 is the host 1, which is the source. And remember that it is from this host 1 that we now sent the echo request. We send the echo request to host 2. That's why the destination IP address here is 10.0.0.12. So this particular packet is showing the interaction and the exchange of information between 2 devices, which is host 1 and host 2. And you see how the first data packet, which is packet 3, is showing the echo request. That means host 1 sent an echo request to host 2, and host 2 now replied with echo reply. Right? Then host 1 sent another echo request. This one replied with echo reply. So if you count data packets here, 1, 2, 3, 4, 5. Remember that one packet is echo request, echo reply makes 1. Another echo request and echo reply will make 2. So we have total of, that's why we sent 5 data packets, and that was what was captured here. Alright, so this is it about that. Now in Wireshark, now if I click any of these data packets, let me just click the data packet number 3, because the packets are numbered. Number the time is the exact time the packet was captured, and this time is measured in hours, seconds, minutes, seconds, and milliseconds. That is how Wireshark actually arranges the time. Then the source you are seeing here is the source IP, while the destination here is the destination IP, and the protocol is the type of protocol. Which type of protocol is the data packet? It is ICMP protocol, and this is the length, this is the information. Right, it is echo request and echo reply. These ones now are other additional information of data packet. Of course, if you're in the class when I talked about the 13 phase in the ICMP, 13 phase in the IPv4 data packet, you'll be able to see that TTS stands for time to live. This one is the sequence number. We have the identification. This other information are there. Alright, so if I click on one packet here, packet 3, if you come to here, you see frame 3. Frame 3 is just referring to this PDU, which is the protocol data unit. If I click on this 4, you see that down here, which is this middle line, it will now be showing frame 4. If I click on this frame 4 to expand it, it will be giving us additional information about the frame, the encapsulation type, the arrival time, and all this other information. If you click on Ethernet, under Ethernet, this is you as a security analyst analyzing a data packet. And the data packet you are checking now is packet 4, which is the frame 4. Under this Ethernet, you are seeing the destination. This is the destination MAC address, and this one is the source MAC address. Compare the destination MAC address and the source MAC address so that you see the source MAC address is the MAC address of our host 2. The source is our host 1. So, and remember that the MAC address here is the source is B6CF. So let us go to our host 1 and confirm what the MAC address is. Alright, under H1 ETA, you see it for host 1, which is the source. You see CA5C. Then let us come here in this frame 4 and check again. Where's that our frame 4? So frame 4 is an echo reply. Let us look at frame 3, which is echo request. That echo request, you see that the source is the H1. So let us go to Ethernet again and check the source. See the source address CA5C. CA5C. This is the source MAC address. And if you go to H1, which is the source, you see that it is the same. Look at the MAC address CA5C. And then the destination address, of course, is going to be the host 2. Look at the destination address, which is host 2 B6CF. Then go to host 2 and check the MAC address of host 2. That is the same thing, B6CF. So you see that the MAC address and the host or the source MAC address and the source and the destination MAC address, they are in alignment with what we got here. Alright, with what we got here. So that is how these packets are being exchanged from this device to the other. Alright, so if you go down now, of course we are going to see we've been able to actually conclude that part. You've seen how the interface of Wireshark looks like. Alright, let me also show you guys more things about Wireshark. Alright, if you come to Wireshark here, this is where you press to start capturing packets. You want to start capturing packets, you click on this place to start capturing packets. If you want to stop the packet capture, you click on this particular place to stop the packet capture. If you want to restart the current capture, maybe you are actually capturing a data packet and you want to restart, you click here to restart. If you want to set your capture options, you can open here and set up your capture options. Then every other thing you need are here. You can zoom in, right? You can zoom in from here and also zoom out. I can click here to maintain the zoom level. So that is it about that. You can also click on file here to open an already captured and saved data packet if you want to analyze it. So you've also known that this top layer, this top region here is where Wireshark actually saves all the data packets, and they are all numbered based on their number and their frame, the time, the source, the destination, the protocol. It organizes this data packet in a way that can be easily interpreted and read by a human being. Why this down here now gives us additional information, additional specific information about a data packet. Now that I click on frame 3, look at how the frame 3 is what is showing here. Look at, if you come to the internet protocol and click that, you see that the internet protocol is version 4. Internet protocol version 4, that is IPv4 data packet. The header length is there, the total length, the identification, the flag, right, protocol, every other header checksum, they are all there. So that is it about that. So the activity is not yet over. The activity said we should actually continue to, after we've opened Wireshark and we've been able to send 5 ICMP packages to this host 2. We've done that. We've been able to navigate the Wireshark window. We stopped it and then we typed ICMP to filter only for ICMP data packet, which we've done. Then we've also gone to the second, to the middle session to do more detailed analysis on the data package. We click the Ethernet 2 and we saw that the destination IP address and the source IP address matches that our H1, the host 1 and H2. And host 2, that's what they say here. Does the source MAC address match H1's interface? The answer is yes. Now the next question is, does the destination MAC address in Wireshark match the H2's MAC address? Yes, we've done that and it actually matched. Note, in the preceding example of a captured ICMP request, ICMP data is encapsulated inside an IPv4 packet, and that is why when we check the internet protocol, we saw that it is IPv4 packet. Now in step 2, we have to examine the captured data on the remote LAN. We need to examine the captured data on the remote LAN. So we are going to ping remote host, that is the host that is not on the LAN, and examine the generated data from those pings. So you now determine what is the difference about this data from this one. So we need to go to our mininet and then open terminal on H4 and open terminal on R1. Let me check how many minutes is remaining in the class, and let's see whether it is something we can continue. Okay, 2 minutes remaining. So if I go to my terminal, I can also open another terminal window for H4, and then if I open that for H4, I've opened a new terminal for H4. Then I'll also open a terminal for R1. All right, I'll just type xterm terminal for R1 and then hit enter. I've been able to open this terminal for R1. All right, so that is what they say we should do here. Xterm for H4 and xterm for R1. This X stands for X terminal. At the prompt in the node 4, enter the IP address to verify the IP address and record the MAC address. Do the same for node R1. So of course, if I come here, look at my node H4. In node H4, we need to check the IP address. You can just enter ifconfig to get the IP address of this particular node, which is 172.16.0.40. That is the IP address of that host, that H4 host. All right, and then the MAC address, of course, is DA:5E. Now if I go here, where is that particular task? You can also do that for R1. So let's go to R1 as well. In R1 interface, I'll type ifconfig as well, and I could see that R1 has Ethernet 1 and Ethernet 2, and their IP addresses are available. 172.16. These things, they are not in the same network with that. This one is 10.0.0.1. So having gotten that, in order to complete the lab activity, we need to record the IP address of H4, R1 Ethernet 0 and Ethernet 1 and R1 Ethernet 2 and their MAC addresses. So all you need to do is just to copy them from here, and then fill it up. The IP address and the MAC address of R1 Ethernet 2 and R1 Ethernet 1, they are all there. So we'll now go again and start a new Wireshark capture on H1 by selecting capture to start. You can also click on the start button, then Ctrl E to click without saving to start a new capture. Okay, then H4 is a simulated remote server. Ping H4 from H1. The ping should be successful. So we are going to ping H4 from H1. So what I will do here is we'll go back here and of course go to node 1, and from this node 1 we are going to start a new Wireshark, or let me just go to the Wireshark we already have and then start a new capture. That's what they said here. Close this capture file. I'll close it, continue without saving. Then I will select ICMP H1 at 0 and then cancel this and start capturing. So when I start capturing, I go to my node 1 and hit enter, and of course ping -C5. The IP address I'm pinging is 172. Let me get the IP address of that our host 2. The IP address of our host 4. That's what we actually need to ping there, which is 172.16.0.40. 0.40. Right, so when I hit enter, of course we could see that the 5 data packets were sent, and if you go to our this, we're able to capture the data packets. Right, so let's continue with the exercise. It said review the captured data in Wireshark, examine the IP and MAC addresses that you pinged. Notice that the MAC address is for the R180 interface. List the destination IP and MAC addresses. So when you open that, you should be able to get destination IP and MAC addresses. So because of time, we are actually going to end it for now and then continue next time. So what did we take away from here? You learned that Wireshark is a network protocol analyzer and TCP dump 2 is a network protocol analyzer. However, Wireshark is a graphical interface network protocol analyzer, while TCP dump is a command line interface network protocol analyzer. You see how the interface of the Wireshark looks like. The interface of Wireshark has a start button where you can click to start capturing. There is a stop button where you can click to stop capturing. There is a restart button, and the interface has 3 levels and layers where it helps you to analyze data packets. The first layer is where all the data packets captured are listed. Look at it, I can scroll up and down from here. They're all listed there. Then this second level, or this middle, is where you can now analyze individual data packets. For example, if I open this data packet here, I can now look into it properly, get more information about it properly from here. I can even click on one data packet here, come to follow, and go to, okay, I can open the TCP stream and all that here, but you can also do that to get all the TCP stream down here. Alright, so this last part here is where the data packets are actually broken down in form of hexadecimal and decimal numbers, which of course we cannot read these ones. So our major focus is on this upper part, this lower part. So you know how to download, how to use Wireshark to capture data packets and then analyze data packets. And this exercise here, this activity here, is going to help you do that successfully. Alright, so I'm recording this video and I'm going to upload it and then send this particular lab activity. It's already there. This lab activity is already there in our folder. When you go to the folder, you go to lab activities, open lab activities, see it here. So you can now watch this video when you install this VM and then practice it.